Good morning and a very warm welcome to all of you watching us from wherever you are around the globe. Welcome to VivaTech, Europe's biggest startup and tech event. First of all, let me introduce myself. My name is Louise Eklund and I'm going to be your host throughout this morning. Thank you so much, first of all, for joining us. It feels really good to reconnect, of course, and revive the VivaTech community after all that we've been through over the last few months. This year, we're going to be bringing together entrepreneurs, startups, corporates, VCs, academics, and media, of course, to ignite growth, business transformation, and, of course, positive change. What we're offering you today is a very special hybrid kind of VivaTech event. We have an amazing program ahead of us for the 4 days to come, with sessions offering obviously both on-site experiences here in Paris, and we're going to be following the rules very strictly, of course, as far as safety is concerned in this pandemic time. And we have an online experience, of course, as well for all of you joining us remotely from around the world. There's going to be over 350 speakers, 500 innovations, and thousands of startups will be joining us to share the best of the world of tech for business and, of course, for society. So let's dive straight into our first discussion today, taking care of the planet. This is, of course, a 2-hour show. If you want to watch it until the end, please make sure you are watching us through the entry stage 3 on the digital platform. We also want you to answer or ask as many questions as you might have. So please use the VivaTech digital platform, whether you're here with us in the audience around me or whether you're at a distance. Of course, you can use the chat to ask your questions. We want it to be as interactive as possible, of course. So we're going to be talking about many subjects in the next couple of hours: climate change, carbon capture, biodiversity, ocean and soil regeneration, issues which can obviously be better dealt with by using the right technology. So let's get down to business straight away. And I'd like to welcome on stage Benjamin Tincq. Here he is. Good morning. How are you doing?
Very well. It feels great to be back at VivaTech.
Doesn't it feel great to have some people around us as
Absolutely.
well? Fantastic.
Absolutely.
So you are the co-founder and CEO of the Good Tech Lab and founding partner of a new climate tech venture studio. I'll get that right. You will be moderating our first discussion here today, Capturing Carbon, Reuse It or Buy It. That's the title. I know that you have been working on the uses of technology to address humanity's biggest challenges for a while now. So maybe we could just start by setting the scene. I think that would be a good idea. How have you seen this sector actually evolve, and what excites you maybe the most at the moment?
Yeah, thank you, Louise, for that question. So I'm very excited in particular by a new field called climate tech. So this is kind of a new word. It means technologies which help to either reduce emissions or absorb CO2 from the atmosphere, or help societies adapt to the effects of climate change. And it's interesting because 3 years ago, that wasn't even a term, actually, and it's being propelled by this new generation of entrepreneurs and founders who, in some cases, like quit their job in academia, in industry, in a previous startup, to make their next project focused only on climate. And what's interesting to see is that people who have been in what used to be known as clean tech before, they really welcome that new energy, this new generation of founders coming, and they almost call it like Clean Tech 2.0, this new climate tech field. So that covers a broad range of fields, from clean energy to energy storage to carbon capture and removal, as we're going to see
Talk
today.
about now, yeah, of course.
Absolutely, to transportation and so on. And sometimes the skeptics will say, oh, we've seen that in the past. Like 15 years ago, there was a lot of investment in clean tech, and a lot of people lost their money, and there was a lot of bankruptcy in these companies. But I think it's very different today, because we see basically everyone shooting in the same direction. We have governments who set very ambitious, aggressive net zero targets.
Yeah.
We see large companies also having large objectives and pressure from their investors, their employees, to decarbonize and to reach net zero by mid-century, so they're going to be the customers of these new startups, obviously. We see investors, including large institutional LPs, who are very interested in, on one side, hedging against climate risk, but also about benefiting from these new amazing opportunities, which basically we are talking about reinventing the entire infrastructure of our economy today. So it's going to be pretty massive. But I think what excites me the most is to see the amazing quality of talent coming to this new sector. So we see scientists, engineers, operators, people coming from different industries, quitting their jobs, sometimes well-paying jobs, to start a very risky new company in climate tech. And as a founder of a climate tech venture studio, so we partner with scientists, engineers, and operators to build new climate tech companies from scratch. Well, basically, we need these people to be able to build great companies. So I'm extremely excited to see them coming to this field.
And we're going to be introducing a lot of people here, yes, obviously at VivaTech, of course, people with solutions, concrete solutions, yes, and we're moving forward. So it feels really positive this moment. Thank you very much for providing us with a little bit of context to get going. I'm going to hand over to you in just a few seconds, Benjamin, to kick off the discussion, capturing carbon, reuse it or buy it. So we're very happy to welcome this morning two guests for this first focus on climate change, and more specifically, of course, on carbon capture. Let's welcome them straight away. Jennifer, CEO of LanzaTech, and Jan, founder of Climeworks, are with us. I think they're with us remotely. Thank you very much for being with us today. Can you hear us? Can you see us? There they are. Perfect.
Thank you very much for having us.
Fantastic. Thanks so much for being with us. Benjamin, it's over to you.
Thank you, Louise. And hello, Jennifer. Hello, Jan. It's a pleasure to be with you today. So maybe to set a bit the stage and introduce your work. So we're going to talk, for everyone who's joining us today, about carbon removal, carbon capture, carbon recycling. So we all know that to reach net zero by mid-century, we need to decarbonize very, very quickly. And that will involve, in some industries, capturing CO2 from point source emissions, including cement plants, for instance, like very hard to abate sectors. But we also know that even if we decarbonize extremely fast, we're going to need to pull out billions of tons of CO2 per year from the atmosphere. And then once we capture that CO2, we're going to need to either sequester it or reuse it. And today I'm very proud and happy to welcome Jennifer and Jan, who've been at the forefront of this new emerging industry, which is going to be really, really critical to meet our climate objectives by mid-century. So Jennifer Holmgren is the CEO of LanzaTech, who is really a pioneer of carbon recycling. Prior to joining LanzaTech, she was a seasoned executive as a vice president and general manager of the renewable energy and chemicals business unit of Honeywell Europe. She's been an author and co-author of many patents and many scientific publications, and recipient of many awards in science and business. We're super thrilled to have you here. Welcome, Jennifer.
It's a great, great pleasure to be here, Ben. I'm really excited about, like you said, the future of climate tech.
And thank you, Jennifer. And we're also super thrilled to welcome Jan Wurzbacher, who's the CEO of Climeworks. So Climeworks is a real pioneer of direct air capture since 2009. So Jan studied mechanical and process engineering at ETH Zurich, where he met his co-founder Christoph almost 2 decades ago. And beyond climate tech, he's passionate about alpine sports, and he's actually said that the effects of climate change on the beautiful Swiss Alps has been one of the triggers that made them start Climeworks in the first place. Welcome, Jan. We're super thrilled to have you here.
Thank you very much, Benjamin. Thank you for having us here. Looking forward to our discussion.
So why don't we maybe take it from the top? We'd love maybe for people who are not necessarily familiar yet with LanzaTech and Climeworks, if you could explain in a nutshell what your company does and how your technology works. I think we have a couple visuals that both of you can show. Maybe Jennifer, we can start with you and LanzaTech.
Certainly. So what LanzaTech does is we use a biological process to convert hydrogen, CO, and CO2 to ethanol and to other products. And I think you're seeing a picture of our commercial plant in China. We have now 2 commercial operating plants, one at a steel mill, one at a ferroalloy plant. And the carbon monoxide that would normally come out the flue as CO2 is being captured and put into our bioreactor, which then converts it to ethanol. The process is just a biological process with bacteria in the bioreactors that you see in the background. And we don't think of ethanol as an end product. We actually think of ethanol as a carrier of the carbon and the energy in the waste resources that we're showing on the slide to the left. What you see is industrial off-gases that we've commercialized, gasified solid waste, or someday coupling with John's technology using CO2 that he's directly captured from the air, plus green hydrogen to make all of the same products. More importantly, through the power of synthetic biology, we're also learning to tailor the products we make. So instead of going through ethanol to jet fuel or from ethanol to other products, we can go directly to those other products. For example, taking the gases to acetone or other chemicals like octanol. It's if you look at the final slide, I just want to show you that we've been able to use our ethanol, like I said, with our partners to make products, so that instead of just using the ethanol for fuel in cars, which hopefully someday will disappear, at least IC engines, we're using the ethanol instead with partners Nobel, Coty, Unilever, to make all the products we use in our daily lives. So we're really excited about a future where carbon recycling makes all the products that we make today from fossil carbon.
Thank you, Jennifer. That was very clear and super interesting technology platform. Jan, maybe you can introduce us to Climeworks quickly.
Yes, very happy to do so. So at Climeworks, we are around since 2009, actually. And what we are doing, we are building plants that capture CO2 from the air. So some of you might have seen pictures already of a Climeworks plant. Those are containerized plants made of shipping containers, which are stacked on top of each other. And the principle is very simple. So our system are built of individual modules. So in these containers, you see units which contain a filter material. And in the first step, we have all these fans blowing air through the filter material, and then the CO2 is captured in this material. You can imagine it as a porous sponge with a lot of holes, a lot of pores where all the CO2 molecules can go inside. And then in the second step, we close these boxes, and the trick is now we heat them up to around 100 degrees Celsius. So that's also very important, that the main energy we need is low temperature heat, which is quite widely available or cheap to produce. And then by heating up the filters, we extract pure concentrated CO2 from these modules again. And then we can start all over again. We've started, as I said, in 2009. Over the past 12 years, we've built up our company quite a bit. Just last year, we've closed a $100 million or $110 million 100 million Swiss francs financing round. We are about 150 employees, mostly based in Switzerland, some of them in Germany as well. And right now, and that is the picture that I anticipate you're still seeing, we are, it's a very exciting time. We are about to commission the largest carbon dioxide removal plant that is based on direct air capture in the world in Iceland. That's the Orca plant that was shown before on the slide. And that plant is located in Iceland, so it takes up to 4,000 tons of CO2 out of the air every year, and then we combine it with safe and permanent underground storage with our partners in Iceland. So they inject the CO2 in the ground, and it turns into stone 1 kilometer underground. So that is our main business model. So we are offering to private customers and to corporate customers carbon removal services. So they pay us to take CO2 from the air and safely and permanently store it on the ground.
Thanks a lot, Jan. That was super clear. So you already gave a few numbers during your presentation, but for people in the audience who really love numbers and who talk about tons and price, and also who like to see how these kind of things evolve over time, can you give us a sense of, like, today, how much CO2 you capture or you transform, how much does it cost per ton, and also to give maybe a perspective, like in the next 10 years, how do you expect all of that to evolve and as you scale up the technology with more customers and more plants?
Sure. I will start at the end. Climate science tells us in order to meet the goals of the Paris Agreement, we will likely have to extract something like 10 billion or even 15 billion tons of CO2 from the atmosphere every year by mid of the century. So that's a huge task to do. And we believe that technological solutions, as we are developing and scaling them, direct air capture, will have to play a major share in that task to do. So to set the goal is to remove billions of tons of CO2 from the air. So that's where we want to go. And eventually, you speak about in terms of cost. If we look at prices of carbon, policy mechanisms, and so on, what we expect is that, like on the one hand, from the technology side, in the long term, this will be possible to do it at the order of $100 to $200 a ton, and that's also where we see current policy mechanisms developing to. So where are we today? So that's the goal. Looking back, we started capturing milligrams of CO2 or then grams of CO2 from the air on a laboratory scale back in 2009. Today, we are at thousands of tons. So we have already a huge scale-up factor that is past us. So it's actually by billions, and we need a bit more. So from thousands of tons, we need to get to millions of tons and then eventually to billions of tons. Obviously, that's not a single company that can do it alone, but it's rather about the development of a whole industry and an ecosystem around that. On the side of Climeworks, we are now doing thousands of tons. Going through, while we move through this decade, we will go to the millions or several millions of tons range up until the end of this decade, and then further scale up as we move through the 30th century. So that's 2030. So
thank you, Jan. Thank you, Jan. And same question to you, Jennifer. Can you give us a sense of like the volumes, the cost, and how this will evolve as you scale up LanzaTech technology over time?
Yeah, so from our perspective, if I look at all of the feedstocks that we can use at industrial sites or gasified solids, not including things like CO2 capture, which of course really multiply the numbers. For us, we think we could make the equivalent of 500 billion gallons of ethanol, which ends up being like taking 700 million cars off the road per year, because what we're doing is preventing carbon from getting into the air and just making products from recycled carbon. This to me is really important because this whole concept of carbon reuse, at the end of the day, if we're not able to keep fossils in the ground by us substituting the products we use in our daily lives from carbon that's already above ground, then I think we're going to have a problem meeting our 2030 target and our 2050 target. And frankly, the 2030 target of a 50% reduction in our carbon emissions is to me a very hard and very near target, which is why I'm really excited. You started by talking about climate tech. This type of tough tech is very hard to deploy. Jan mentioned 12 years. We've been at it for 15 years. You really need a lot of time, a lot of cash, and a lot of steel in the ground. And so we just really need to accelerate and move faster to meet the 2030 numbers.
Jennifer, for that. And maybe like a question that is very specific to you. So today, as you explained, you work with either CO or hydrogen or CO2 as feedstock. For the CO2 part, how do you see like the different source of that CO2 to evolve over time? Which kind of source are you focusing on right now? And do you imagine a future where maybe your process could plug into, for instance, what Climeworks is doing and working with atmospheric CO2 at the same time?
Yeah, so absolutely. So the way to think about what we do is you have two molecules that carry carbon, CO, which has carbon and energy, and CO2, which only has carbon. And so for us to be able to use CO2, we need a hydrogen economy that is green to develop. That is where the organism that we use will pick up its energy from. And so that's very important. So I see our technology transitioning from steel resources and ferroalloy resources and refineries where there's quite a bit of CO to a situation where all of these industrial locations transition to other sources of carbon so that we only see CO2. And so then our technology will have to couple with hydrogen. This transition will be important. Do I see ourselves coupling to direct air capture? No question. We should definitely be able to take the CO2 that's been directly air captured. And we're really excited about that prospect. So in some ways, that is there's two types of power to X, right? What they call power to X, which is CO2 plus power where the hydrogen is generated to make products, right? X, whether it be fuels or chemicals. That can happen whether it be CO2 from an industrial resource like a flue gas or CO2 that has been directly air captured. So the future is bright in coupling all of these technologies together, as Jan said, to create an ecosystem that significantly reduces carbon.
Thank you, Jennifer. This is super inspiring. Jan, I have a question for you. So I'm fully convinced about the potential and the role that direct air capture will play in the future. But sometimes you hear like skeptics who are like, oh, but do we really need that technology? It seems expensive, and maybe like nature-based solutions, reforestation and so on will be enough. So when you hear this kind of skeptics' arguments, what do you answer to them?
Yes, thank you, Benjamin. Well, first of all, if we think about natural solutions, just to make sure we speak about the same thing, so most people referring to planting trees, afforestation, and my very first answer is yes, absolutely. We should plant as many trees as possible, and wherever we can do that and we can achieve that, that's a very good thing to do, because it has also, typically, if you do it in a good way, it has positive side effects. The downside is, if we look back in history, and typically it's good to try and learn from history, over the past 100 years, like many people have tried to avoid cutting down trees or deforestation, and we haven't been successful with that. So if we look to the future and say, like, we have this huge challenge ahead of us to solve, and if the only bet we would place would be on something that we have tried for the past 100 years, but it hadn't worked, that might be a tricky one. And that's why I believe we should have more to look in. And on the other hand, if we look at how humans, or we as a world, have been in scaling up industrial solutions, that has been quite successful. There are many success stories, and I firmly believe that it will be possible to scale up technology as a speed as we need it. So this will be a favorable, can be a very successful approach. And we also have to keep in mind the scale. If we want to solve the whole problem by natural-based solutions, that will require a lot of area. So we might have to plant trees on an area as huge as Europe, as an example. It depends on what type of technology you need to know, but it's not an easy one to do. So we need to do many things. So yes, let's plant as many trees as possible, and let's develop the tech in parallel, and let's use both to be even faster in achieving our 2030 and 2050 goals.
Thank you, Jan. I couldn't agree more. A question to both of you. I'd love you to tell a bit more about your customers and who they are today, and also why they come to you. What are they paying for? Is it mostly for the climate benefits, or is your product offering something else that they couldn't get with other products they use to use the same to do the same thing? So maybe Jennifer, you can start.
Sure. So first of all, our customers are paying for climate benefit. That is, a lot of them are very interested in recycled carbon. So the first to introduce ethanol into cleaning products, in other words, outside of the gasoline work that we're doing in China, was Mebel in Switzerland. Their stores have household cleaners made with a recycled carbon ethanol. They do pay more. At the end of the day, it's not just about the technology making a product, but because the materials are available, the products are available on a small scale, you're also building an entire supply chain, a new supply chain. And initially, even that costs extra money. you're competing with something that's been around for 150 years. And so trying to compete on cost doesn't work. Does the product have benefits in terms of new properties? No, right now we're just displacing products that used to be made from fossil carbon. In the future, we'll introduce new molecules, but right now we just want to try to take fossil carbon, fresh fossil carbon out of every equation. And frankly, it's in everything we use in our daily lives. And so our first goal is to do that. But our customers are willing to partner with us to pay more, whether it's our aviation customers, our perfume customer, Coty, etc. So we're really excited to work with those first movers who are willing to help pull the technology by helping us by paying a small premium.
Thank you, Jennifer. And Jan, same question to you. Who pays you to do carbon removal today?
Yes, so our customers are, on the one hand, private individuals like you and me. Over the past years, we've been approached by many people. They asked us, hey, it's so great what you're doing at Climeworks. Can I be a part of that? Or can I do something for myself? And based on that, more or less exactly 2 years ago, mid-2019, we launched a new product, a carbon removal solution for everyone, which you could find on our website. So everyone could purchase a subscription to pay Climeworks on a monthly basis to remove CO2 from the atmosphere in her or his name. So that's the first thing, and that is really based on a huge demand we have seen from private customers. On the other hand, our customers are corporates with ambitious and pioneering climate goals, so with net zero or even net negative goals. So there are like 3-4 years ago, it was really difficult to place this on the market, but in the past 12 to 24 months, this has really flipped around extremely, and we are getting many inquiries, and we are really proud to have famous names on the list of our customers, such as Microsoft, Stripe, Shopify, car maker Audi, who are purchasing carbon removal solutions from Climeworks for a simple reason, because currently there is nothing else on the market as safe and as permanent and as additional as we can offer it. Also saying with that, it is still much more expensive to purchase carbon removal from Climeworks than with other solutions, but that's not an apples comparison. So what we can offer is, if we offer a ton of carbon removed from the atmosphere, it is more or less perfectly metered. And when we speak about permanence, we are speaking about millions of years. So we are not speaking about tens of years, or not about solutions where you might worry about a forest that you have planted that might burn down 20 years down the road. So again, we should do it, but we have to keep that in mind. So if you pay money to plant trees, you might, to have the same effect, you might have to do the calculation. I might have to do this 10 times in a row, or even 20 times in a row over the next hundreds of years in order to get to a similar effect. And that is why customers are trusting in the Climeworks solution for this permanence, and because they believe that when we are scaling this, we'll getting substantially down with the costs, and we will be able to offer much more volume at much lower prices in the future.
Thank you, Jan. I really love that you're having both companies and citizens as our customer. I'm actually myself a monthly subscriber for the past year, and so I invite everyone, if you want to take action, you can go to Climeworks and start to remove carbon from today.
I wanted to hear. Thank you, Benjamin.
I wanted to hear about fundraising from both of you, because as you mentioned earlier, Jennifer, building a deep tech climate company is really hard. It takes a lot of time to go from the initial research to building a company to commercialization. And it used to be known to be like extremely difficult to fundraise in clean tech and in that sector. But like both of you, you have raised like very large amounts of fundraising to build your company. And I'd love to get your feedback on how was the process, and also how you have seen this landscape of investment in climate tech evolve in recent years. So whoever wants to start first. Jennifer, maybe.
Sure. So we've been around for 15 years. The company's been around since 2005. And we have raised over $500 million in that period to get the company to the point we are now. It is really hard. You know, there's a lot of, you knock on a lot of doors and you get turned down a lot. But you find some people that are very well aligned with what you're doing and your vision. And we have been very successful in doing that, but we've had to do it globally. You know, we are not a US company that's raised money just from US VCs. We have US VCs, we have New Zealand and China VCs, but we also, and this is actually one of the important parts for us, is we have strategic partners, a lot of strategic investors who not only have invested in the company, but have also invested in building commercial facilities or doing a JDA with us to develop a piece of the technology. So to us, that's also been really important because the help from these very large corporates and strategic partners has also taught us a lot. So it's not just about the cash, it's about learning how to integrate into a steel mill or a refinery. It's about learning how to sell a specific product, how to deal with a specific chemical. So a small company, we have now 200 people, but you can't know everything. And so these partners have really helped us. But please do not underestimate how hard it is. Don't do that. It's a long, long road, and it is a very hard road.
Thank you, Jennifer. Jan, same question to you.
Thank you. Well, first of all, from my side, big congratulations to you, Jennifer. I think it's really a great achievement and a great landmark for the whole community and for the whole domain. And I think others should look at that if they are worried and think, well, how could I go ahead and finance that? On our end, a bit of a different strategy so far, but again, it's a continuous process. Before fundraising or after fundraising is before fundraising typically on our end. I'm sure it's the same on your end for LanzaTech. We have raised so far about $170 million in over 5 financing rounds. The key that we have always used, we have looked for financing partners with a really long-term financing horizon. So we have hardly any institutional investors in our shareholdership. So the shareholders of Climeworks, the investors, are almost exclusively private individuals or through their family offices, entrepreneurs from Switzerland and surrounding countries with a very, very long-term vision. I like to joke saying a quarter to them is not 3 months, but it's rather 25 years. And all the efforts we've spent in investing is trying to get a group of investors, to assemble a group of investors and continuously extend that is really believing in the idea, in the concept of building up an entire new industry. And that is it's surprising how many people are intrigued by this idea and much more intrigued by the idea of building up what could be one of the world's largest industries in 20 years down the road, compared to making a lot of profit in 3 years down the road. So that's the path we've been following, and we try to continue that for the next rounds as well.
Thank you, Jan. I see we have time for maybe 2 quick more questions, and I'll leave the last one to Louise because I know she has one she would like to ask at the end. My last question would be, what do you think is the role of policy to help that sector to develop? Like, what's going to be the impact of a high or low carbon price on your companies? What are some examples of good policies you've seen? And maybe specifically, what can and what should Europe do to help that sector to grow?
Jan, go ahead.
Well, happy to go ahead. So I think a good policy at this point in time is a bold policy that acknowledges that we need to invest quite a bit right now in order to be successful 10, 20, 30 years down the road. So a policy should not be too hesitant. It should not, and a policy should consider it doesn't really matter so much if we really look at it from a long-term perspective. How much does a particular technology, instance of a solution or a particular plant we are building today, how much does it cost? Like I'm getting this question all over the time. How many dollars per ton? Where are you today and how many dollars per ton? And my preferred answer to that is that really relevant? I think it's relevant how many tons can we capture in 20 years down the road or 15 years down the road, and what is the cost then? And the best way there might not necessarily be the one where we are like trying to optimize everything right now, but it's really about scaling now. If we look at other industries such as photovoltaic, wind industry, they manage to scale by building up like an ecosystem, an environment of an industry. And to kickstart that, we need policies that allow that. And then this industry will help scaling and bringing down the cost. And what is a good example? That's what you asked. I think what in Germany has been done for the solar PV industry, that is a really good example. That was a bold policy. Many people have been complaining about huge costs, but in the end, that has kicked off an entire industry, which today turns out to be the cheapest way of producing renewable energy.
Thank you, Jan. Jennifer, quick answer, and then last question from Louise.
Sure. Yeah, so policy is hugely important. If you're doing something that's new or a disruptive approach, often you find that policy is not technology neutral and it only favors the incumbents. And so as hard as it is to scale and commercialize new technology, often you're not even allowed a seat at the table if it's something very different. So policymakers need to accelerate the path by which they allow new approaches. It has to be technology neutral, like the low carbon fuel standard. It's just in California, it's just about an outcome. Carbon reduction is not about how you get there. So I think this is super important. And I think the rate at which we do things is important. You know, technology evolves exponentially. You build a few plants and then it grows quickly. As you're growing them, they come down the cost curve. You see that in solar, etc. And we need to see it in climate tech. And most importantly, we all have to remember it's not one approach versus another. It's about getting all approaches out there. We have to move as fast as we can, which means one approach will not be enough.
Jennifer, thank you. I'm sorry, I'm going to have to cut you up, guys. We're coming to the end of our session, but it was absolutely fabulous. We learned a lot. Thank you very much to both of you, Jan, Jennifer, and Benjamin, for being on the set with us today. You want to finish with a quick word?
Thank you all. It's been a pleasure to be with you today.